In the last video, we talked about osmosis and the movement of water. So think about what happens when you fill a balloon with water. The balloon swells as well, right? So what would happen if I took a cell and I put it into a solution of water and other stuff? Well, one of three things can happen to that cell. The first thing is that the net movement of water is zero. There's no net movement of water. These are what we call isotonic solutions. Isotonic. Okay? The same tone. That's where that comes from. The same tone, right? So the tone of the cell, the degree of pressure on the cell membrane stays the same. Okay? I can take a cell and I can drop it into solution, and water can rush out of that cell. And when that happens, that cell is going to shrivel. This is what we call a hypertonic solution. The cell shrinks or shrivels. Okay? The third thing that can happen is that I can take a cell, I can put it into solution, and water can rush into the cell. When that happens, the cell will swell. It'll get bigger in size. This is what we call a hypotonic solution. Okay? So three different outcomes when we put the cell into solution. The cell can shrink. It's a hypertonic solution. The cell can stay the same. It's an isotonic solution. Or the cell can swell because it takes up water. And this can often lead to cell lysis or cell bursting. Okay? That's a hypotonic solution. So think about what dictated the movement of water from one compartment to the next. What would dictate the movement of water across the cell membrane? What would decide whether, when we place a cell into solution, does the cell shrink? Does it stay the same, or does it swell? I want you to think about that for a minute, and when you're ready, watch the next video as we compare osmolarity, the amount of stuff in the solution, to tonicity. You might be surprised.